So this quiz is about functions and their inverses. First we start off with a problem that's algebraic in nature. And really here we're just contrasting, evaluating the function versus evaluating the inverse. So f of -2, that's just simply putting -2 in for x. So that's replacing x with -2, and we get -2/5 plus 4. And of course 4 is 20/5, so that's 18/5 as an answer. So f inverse of -2, well, one way to do this is to think about this as a question where we're trying to figure out what letter this is. So f inverse of -2 is t, say I'll just make up a letter. And my job is to figure out what t is. The reason for thinking of it that way is that any equation involving the inverse can be written as an equivalent equation involving the function. So I can just change this around, and that's the same question. So the input-output, sorry, -2 here. So the input-output swap when I change from the inverse function to the function. The reason that makes it easier is because this latter equation, f of t, we have the algebra formula here for f of x. So f of t literally just means 1/5 t plus 4. So what I'm solving here is when is 1/5 t plus 4 equal -2? If I subtract 4 from both sides and multiply both sides by 5, I'll see that t should be -30. So the answer to the question then is -30. So f inverse of -2 is -30 because f of -30 is -2. When we do this in the context of a graph, it's pretty much the same thing. If you did problem 3 first and drew a picture of the graph, then you wouldn't have to think hard about the answers to these. But again, let's assume that we're just trying to answer just this isolated question. G of -5 means when the input is -5, which is here, what's the output? So on the G graph, this point has coordinates -5, -3. And so that means G of -5 equals -3. Input, output, x and y on the graph. So just like the one before, if I have a question about the inverse, I could say, well, let's write this as an equation. G inverse of 4 equals t, make up a letter. The equivalent equation is G of t equal 4. And so what I'm looking for on the graph then, the output of the function is the y-coordinate. So I'm looking for where's the y-coordinate equal to 4? Well, here's 4 on the y-axis. So the graph is 4. The graph has a y-coordinate of 4 right there. This point on the graph is the point -1, 4. So the fact that -1, 4 is on the graph means that G of -1 equals 4. So in other words, in this equation, t should be -1. So -1 is my answer. Here, -3 was my answer. The last question here is just to sketch a graph of the inverse, and so that's fairly easy to do if there are points that are easy to read. In this case, the points have been drawn, hopefully, to be easy to read. So all I'm doing is I'm swapping the x and y coordinates of the points that I can read easily on the graph. So again, this point was -5, -3, so on the inverse, I should have the point -3, -5, which is here. This point is the point -3, 3. So on the inverse graph, I should be plotting 3, -3. So again, I'm just changing the x and the y coordinates. We said the point -1, 4 was on here, so it must be the point 4, -1. So there's another point. It's on my inverse graph. Here is the point 1, 5, so the point 5, 1 must be on my graph. It's kind of hard to get that right. And then finally, I'm going to run into this thing. Finally, the 0.86 is here, so the 0.68 should be on the inverse. So it's really in the way. So now if I just connect these with little straight line segments, so go from here to here, go from here to here. I need to make that line. And then here to here. So this is what my G inverse function, this graph will look like. It ought to look like I have made a mirror image across this 45-degree line that has equation y equals x. So it ought to look like a mirror image across that diagonal line.